is CORDIScovery. Hello and welcome to this episode of CORDIScovery with me, Abigail Acton. Energy, world grain supplies, consumer goods, so much more. Ships transport a remarkable 90% of the world's commodities. As the United Nations Secretary-General António Guterres said, without ships and the women and men who work on them, economies would stall and people would starve. Vital to the flow of the commodities we all depend on, seafarers often work in dangerous environments. And the pandemic revealed how vulnerable they are to social restrictions. The United Nations estimated 400,000 seafarers were prevented from going home in September 2020, often stranded on board as the pandemic forced the imposition of travel bans. In recognition of all we owe them, the International Maritime Organization founded the International Day of the Seafarer back in 2011, and it falls on the 25th of June. So this episode, we're looking at how EU funding is working to make life at sea safer for passengers and for crew. Today's guests, whose work has been funded under the Horizon 2020 programme, are Franz Evegren, who is the director of the Fire Safe Transport Unit at the Research Institutes of Sweden, RISE. Franz focuses on using innovative technologies, operations and applications to reduce the incidents and impacts of fires on board roll-on, roll-off car ferries. Welcome, Franz.
Thank you very much, Abigail. It's nice to be here.
Also at the Research Institutes of Sweden is Luis Sanchez-Heres, senior researcher at the Maritime Department. Luis is interested in harnessing the power of AI and machine learning to improve safety at sea. Welcome, Luis.
Thank you, Abigail. Thanks for inviting me.
Lazaros Karagianidis is concentrating on how smart applications and wearables can make ship evacuations faster and safer. Lazaros is based at the National Technical University of Athens, where he is senior researcher and project manager at the iSense Group. Hello, Lazaros.
Hello, thank you for having me.
Very welcome. Wonderful that you're here with us. Franz, I'm going to turn to you first. The Lash Fire project is developing operational and design solutions to improve fire prevention and, where fires do break out, ensure better management on roll-on, roll-off ferries. Franz, the public doesn't necessarily really hear much about fires on ro-ro ferries, but the International Maritime Organization has decided that more needs to be done to prevent them from breaking out. Can you tell us a little bit more about the context, please?
Yes, in fact, there have been quite a few fires on these so-called roll-on, roll-off ships, or ro-ro ships, as we refer to them, carrying vehicles. So you roll on and roll off the vehicles. And if you look at the past incidents, there have been about 2.5 major fires on these ro-ro ships every year. You might have heard of a couple of them in the Mediterranean. There have been a few significant fires on the Norman Atlantic and Sorrento. But there have been quite a few fires, and this was picked up by the International Maritime Organization, which is a United Nations specialized agency, more like a global parliament for ship safety, including all the nations and a number of recognized organizations internationally. So they decided that something needs to be done, and they also opened up for regulations to change, and that's where our research really came in.
Right, super. Thanks very much for that explanation. Okay, that's interesting. So clearly there is a need to work out what can be improved. So what are some of the potential solutions that the project identified relating to the issues that you've just talked about here, about the incidence of fire?
So yeah, in our project is based on a number of previous projects where we identified a number of challenges that have caused these fires. We looked into past accidents, of course, and we also looked into the future on the coming changes in like the reformation of the vehicle fleet into a larger use of batteries, for example, or hydrogen as fuel. And the issues came down to a list of 20 challenges, which we grouped into partly the 4 stages of a fire, if you may say. So prevention, detection, extinguishment and containment. And we also had 2 work packages focusing on the operations, so the people and what they do on board, firefighting, for example, and also on the design interface between the humans and the technologies, which has often been a cause of confusion and caused larger consequences of fires, you may say.
Can you give me some examples of what you just mentioned there about the human interface with the technology, of where that's gone wrong in the past?
Absolutely. So, for example, it might be the case that when you get an alarm on the bridge, it says that the fire has occurred by frame this and deck that in the starboard part of this. And then you might have a CCT camera with a numbering. And then you have, if there is an established fire or confirmed fire, you need to activate the extinguishing system in a section. And all these systems are individual and causes or gives a lot of ground for mistakes, you can say. So, and even if when you come into the drench room where you activate the drench sprinkler system, there might be different numbering on those valves compared to the sections on the deck, so to say.
And all of this under a time of great stress and urgency, where really you want things to be smooth flowing.
Right. And in a panic or a very stressful situation, things need to be easy to make correct.
Yes, exactly. Not trying to struggle to find the right answer. Okay, that's a great example. And you talked about the likely move towards electric batteries for vehicles and stuff like that, the hydrogen you mentioned as well. Mm-hmm. So what were some of the solutions that you were thinking with regards, for example, to anticipation of fire?
Well, we have looked into detection of the thermal runaway of a battery in an electric vehicle as well. That, I would say, is the area which has not come so far. We weren't addressing that in the project, but we're looking into it a little bit now. And in a lot of aspects of the project, we have actually transformed a little bit because of the large need coming from the operators and from the crews asking how to handle this new situation. What we have done is we have looked into how to safely charge a vehicle on board. We have looked into whether or not the current extinguishing systems would be sufficient to control an electric vehicle fire, for example, and things like that. So we have adapted parts of the project to really consider the future reformation of the vehicle fleet.
And as you say, the request from the crew, because I know that you're very interested in having the feedback from crew.
For sure.
From the actual seafarers.
Right. And like I said, many of these challenges that we're addressing, they really come from the crew and the concerns and the hazards that they see. And from the, like I said, the different fires, the incidents in the past. And we really want to make sure that our research is not becoming a shelf warmer, but really comes to...
Yeah. Not just academic work, but has practical solutions.
Of the project.
Yeah. Franz, what sort of cutting edge technology are you using, for example, for fire detection? I know that you mentioned perhaps looking under the vehicles.
Right. So we thought it would be very exciting to look into the potential of using drones. So we've done that in different ways. We've done it, for example, you might be aware of that drones are now used for man overboard exercises. So you can send out a drone to if a man falls overboard to locate the person. And we also use it for getting an overview of the fire. But we also use not flying drones, but rolling drones on the deck that can roll underneath the vehicles and with the heat cameras and the sniffers or smoke detectors and etc. And they can be quite well equipped because you don't need so many, and they can kind of control the area when no one is on board anyways.
And maybe areas that are inaccessible.
Right. And in particular, since the batteries are usually located very low in the vehicle, it makes sense to kind of be underneath the vehicle when you scan them.
Yeah. And I guess you could have them sort of like caterpillars going along most of the time throughout the voyage, really, and just kind of doing tours.
Right.
Yeah.
So that's what we're looking into, and we've developed a pilot or kind of an example of how such a drone can be developed and used on board. And it's quite exciting to see it work.
Yeah, no, it must be. And very satisfying. And also very satisfying for the seafarers to feel that they're actually being heard by someone in a position to come up with some solutions. Okay.
Right.
Any other kind of solutions or problems that were identified that you are beginning to think of ways of handling them now?
We are trying to use a quite high so-called technology readiness level. So we want to really make solutions that can have an impact right away, not core research, you may say. One of the things that we have looked at is screening all the cargo before it goes on board to look for hotspots on board. These are systems that exist for other valuable infrastructure such as tunnels, and we thought it would be very useful to also do it for the ships. So we've developed a system there that is now being demonstrated for some of the operators that we work with.
So if I can just stop you for a minute, Franz, I'm really interested in what you've just said about the notion of something that can scan the contents of vehicles to see, I suppose, if something is potentially a flashpoint, could be a risk for fire hazard. that exists already for going into tunnels, you mentioned.
Right. Yeah, there are companies focusing on this, and so several or a couple kilometers before the tunnel, usually they scan the vehicle so that they well in advance can set these vehicles aside, which have ignition sources or seem to be overheated, and combined with AI, these systems are quite smart. They can really see if it's a part of the vehicle that should be hot or if it shouldn't. So
fascinating, yeah, and of course it's really clear what you say. There's clearly a process that could be useful there for ships and boats coming on board.
Right. And then we have also looked into extinguishing systems on the weather deck, for example. The weather deck is the deck which you usually see from outside the ship, where you can see the actual cargo, the vehicles on top. So they're totally exposed to wind and to the weather. And previously, there haven't been any extinguishing systems or detection systems for these decks. So now we're really trying to identify and find systems that would work in such a harsh environment.
Yeah, I mean, as soon as you mentioned it, of course, it must be very difficult, because you usually think of sprinklers and things like that as drenches coming from above. And if there's no roof...
Right, you don't have a ceiling.
Yeah, no, fascinating. Thank you so much. This is really, really interesting. Franz, why did you get involved in this research? What was it that pulled you into this area?
Well, I've always been kind of drawn to the sea, I guess, and I knew I wanted to become a fire safety engineer and a risk analyst. So I thought that would be a great combination. And I also sailed for a few years, and I really know how it feels to be alone at sea. And when you have felt the big waves of the Biscay, or I actually was in one experience I had at the North Sea when our ship was breaking down a little bit. So we had to search emergency harbor, and I really felt small and far away from help. And even if you're on a large ro-ro ship, I think that the resources are very limited. And in case there is a fire on board, you really need to be able to manage it on your own on the ship. So that kind of drew me into this area, and I hope to make an impact to make it safe from them.
I'm sure you will. It sounds already as if some of the ideas you're having and the ability to give seafarers a voice as well are definitely going to be making a difference, if not already. Thank you very much, Franz. I'm going to turn now to Lazarus. Lazarus, SafePass wanted to redefine evacuation processes, systems, and equipment. Your project looked at better ways of monitoring hazardous situations on board and informing passengers and crew about the safest, quickest evacuation routes. So we've been talking here with Franz about shipboard fires and how to prevent them. But Lazarus, if a fire does break out that can't be controlled, can you tell us what's involved in an evacuation in current circumstances, please?
Yes, so once the situation is assessed and the passengers are not safe anymore on board, an evacuation will be, of course, initiated. And this involves the announcement of an evacuation signal, the announcement through the public announcement system to the passenger to move to a safe place, which is called muster station. And in this process, the crew actually facilitates and guides the passengers to their muster stations, and then to their embarkation stations. But this whole process currently is a quite static process, meaning that passengers need to move to their pre-allocated and designated muster stations, and they have to follow the static, let's say, exit signs, well-known exit signs, and they have to wear their life jackets and so on. The current problem with the situation is that there might be situations where passengers are located far away from their designated muster stations. Secondly, there might be evolving hazards like fires or flooding that may block existing evacuation routes or even the whole muster station. So we need solutions that actually can, first of all, adapt to the evolving nature of hazards and adapt a bit to the evacuation strategy, and also introduce novel means of evacuating passengers, not only relying, by the instructions by the crew.
Okay, that's clear. And indeed, I mean, any of us who've been on ferries, we've all seen those muster signs. And clearly, if you're at the other end of the ship getting a coffee, it's not necessarily the most practical place to go back to. So who did you work with in order to come up with a definition of what needed to be changed? And once you'd realized what needed to be changed, what kind of ideas did you have to improve the situation?
Yes, first of all, in our consortium, we had the chance to collaborate with different disciplines and backgrounds, for example, with academia, with shipyards, with cruise line operators, with ICT and software providers, but even with lifeboat manufacturers, as well as organizations that are dealing with regulations and also independent ethics and personal data experts.
Oh, let me stop you for a second. I can see the logic of all the various groups that you're talking about there, but the personal data experts, this is fascinating. Why would they be brought on board? What's the relevance of data protection there?
Yes, because the solutions we are implementing also deal with personal data, such as the ID of a passenger, such as the location of a passenger. So in order to be compliant with the current GDPR regulations, I mean, the personal data protection, we had to ensure that we are really compliant with those regulations, and we need to take into account these, our solutions, all these regulations.
So you got this really kind of diverse team of experts, but practical and legislative. That's excellent. And what were some of the ideas that you came up with the help of these diverse people?
Yes, some of the ideas, and especially from the shipyard and the cruise line operators, was to first of all identify the mission and operational requirements during an evacuation. So we found out that the static evacuation process is not that efficient, and this could be, let's say, an area of modification. So we came up with the idea of a dynamic evacuation, let's say, process, which means that we actually know the location of the passengers at any time using indoor localization systems, the mobile devices, and the smart life jackets that we have implemented. We can calculate the safest and fastest evacuation route based on the current situation on board, especially when we are having fires or flooding that can block some routes. We can calculate this safest evacuation route in real time and then inform the passengers through their different mobile devices or the dynamic exit signs, in contrast to the, let's say, static exit signs.
So hang on a second. So by dynamic exit signs, we mean basically exit signs that would illuminate depending on a context.
Exactly.
Right.
So these are digital displays that in case there is a blocked route, it will indicate that you should not follow this route. You should follow another route, another corridor to go to your master station. Exactly.
And I believe you also considered what would happen in the case, horrible idea this, but I mean, I guess it does happen, unfortunately, in the case of limited visibility where people can't see things very clearly.
Yes, this was also one of the major aspects we had to look in. So we came up with an idea of a smart life jacket. So in case you have a limited visibility, you can activate a haptic navigation process, which means you can feel vibrations on your life jacket that indicate the direction you have to follow, or even activate an audio navigation through a speaker, which tells you which direction you have to follow. And all this information is processed at the, let's say, central processing platform that shares this information to the life jacket, but also the mobile devices and so on.
And that's absolutely wonderful. You're already making me feel safer. Both you and Franz are making me feel safer about my future ferry trips. And I use ferries a lot, so I'm a nervous flyer, so I like boats. So Lazarus, though, can you tell me a little bit about training? Because this is all when we're in the middle of a really tough situation. But I believe you've also done some anticipatory work in the form of training.
Yes, exactly. The main, let's say, need was to provide some novel training means, especially for the handling and operation of the lifeboats, which are deployed on the cruise ships. So we implemented an augmented reality application that provides intuitive and easy to use, let's say, AR glasses, and play back different kinds of training scenarios as well as maintenance scenarios. So as the crew is, let's say, better trained and has a better experience, a better training experience, through these devices.
So they can have an understanding of the impacts of the choices they make in a particular context and what that actually means in terms of how easy it is to deploy the lifeboat or if it's deployed at the right angle.
Exactly. And also the good thing is that these type of training can actually be conducted at any time and at any place.
Yes.
So you don't need actually let's say, a lifeboat, or you don't need to be on board to make these trainings. And this was well appreciated by the trainers.
Yeah, it's well appreciated by me as well. That's excellent. Thank you. Very good. This is wonderful. Can I open this up and ask, does anyone have any observations to make to Lazaros or any questions?
Yeah, I have a question.
Yes, Franz, please.
I was wondering, Lazaros, hi, by the way. As I understood it, you looked at how you could alter the route to the muster station or assembly station in a smarter way, based on that the actual location or local positioning of the passenger. Have you also looked at maybe optimizing instead the muster station designation for the different passengers, so based on the location of the passenger, so that you go more to the closest muster station instead?
Yes, this was actually exactly the principle or the process we followed. Of course, taking into account always the IMO regulations and the specifications of the muster stations, but knowing the exact position of the passengers, we could actually guide them to the closest and safest muster station, of course. In some cases, even, we did not even go through the mustering process and directed them directly to the embarkation stations, which reduces very much the evacuation time.
Right. It's a very interesting subject. I think we actually used a similar principle in the Lashfire project, where we there's something called a runner, or someone gets an alarm to go to the place of the alarm to confirm whether or not it is a fire. Most of the times it's not. It's a false alarm. And instead of having one designated person to do that, we send an alarm to the closest persons, maybe the 3 closest crew members who are trained to investigate whether or not it's a fire. So with the same principle that where all the crew members are.
Yes, about maximizing efficiency.
Right.
It's the complementarities between the projects.
Oh, absolutely. And I think you two have a lot of overlaps as well. I mean, I think it's fascinating. Thank you so much. I'm going to turn to Luis now. Luis, onboard safety also depends on highly accurate location positioning. So we've talked about what would happen on board with a fire and how we would deal with that if we, unfortunately it did actually occur. But Prepare Ships, your project, is exploring the way artificial intelligence, advanced sensing, and Earth observation data all interconnect, not only to determine where a ship is now with greater accuracy, and you're doing it with very great accuracy, I look forward to talking about that, but also where the ship will be, which is an important element for autonomous vessels. So can you tell us how current systems work and what the drawbacks are?
Well, currently in a ship, you basically use a GNSS system, which is a global navigation satellite system. The most common one that we talk about it every day is the GPS, the Global Positioning System, which is from the United States. But there's other GNSSs such as Galileo or Beidou from China. Galileo is from Europe. And all these systems, they tell you where you are in the world, and then you can pinpoint your location in a map. But this location that you get has a certain accuracy. So for example, GPS is a certain accuracy of a couple of meters. But then you can use different extra systems to get higher accuracy. For example, you can use something called satellite-based augmentation service that gives you maybe 1 meter accuracy, and then you can have other type of corrections, like something called RTK that will give you centimeter corrections, or PPP corrections that will give you decimeter accuracy location.
Okay, but at the moment, I believe you think of the positioning systems as being either dynamic or, as you say, kinematic. Can you explain what these two types are?
Well, one thing is determining where you are. So where you are in a ship, it is determined by usually GPS or visual observations or radar. That tells you where you are. Where you're going to be in the future, that's a completely different problem. So usually you use your velocity to determine where you're going to be in the future. And that you could call it a dead reckoning predictor or a kinematic predictor. It's like, I'm moving in that direction, I'm moving at 10 meters per second. Therefore, in a second, I'm going to be 10 meters ahead. That's it. But the alternative to that, and it's important for ships, is that you, instead of predicting your future position with your current velocity, you can predict your future position with the forces being exerted on a vessel. And this is very meaningful for vessels because they're so big, they have such a large mass and moment of inertia that these forces are acting and they have consequences that are evident forward in the future.
So we're talking about things like currents and wind, and when you say forces.
And the propeller and the rudder and what it is.
Right.
I never sailed a real vessel. When in a simulator, you turn the rudder and nothing happens. And then you get desperate and you turn it a little more. And then suddenly the vessel is turning and you lose control because you don't have the right feeling that what you do right now, you're going to see the effects in the future. So from the point of view of control, it's actually quite challenging for somebody who's not trained for. And because of this problem, even for people who are experienced, if you have wind and currents and other vessels in the round, then, okay, where am I going to be in 1 meter time in the current situations? You have an idea. That's challenging. Then seeing another vessel that it's turning and looking at its velocity vector and saying, okay, where is that vessel going to be in a meter time? That's even more challenging. So in this Preparedness project, there was one part of it was the predictor system, which actually uses information from on board a vessel and machine learning to predict where that ship is going to be at a certain amount of time.
Okay, so let me ask you then, can you break that down a little bit more in terms of how that all comes together? So, because I know that you're very interested in the use of artificial intelligence to crunch big data. So where are the sources of the data coming from? Earth observation, and as you say, the forces and so on, and how are they coming together for you to interpret?
All right. So we have a Galileo, which is the European GNSS. And then we also use corrections from the Galileo system, which is called HAS, Accuracy System Service. And that gives you these corrections, and we get a position in a map. Says us, okay, latitude, longitude, we are here with decimeter accuracy. Then we use that information and we mix it with information from the rudder, from the anemometer, which is the thing that measures the wind speed, and so on to calculate forces. And we put these forces into a model, a dynamic model. Now, this dynamic model is a bunch of equations with some parameters and coefficients. And these coefficients, we have learned them through experience. We record where we have been and where we are, and we use that information to adjust with machine learning these parameters, and then we can make a prediction out of that.
That's fascinating. I know that you were doing a pilot in Gothenburg Harbor. Could you tell us a little bit more about that? And your notion, obviously, is that you want the artificial intelligence to do the heavy lifting when it comes to the assessment of all the data and the interpretation of the data. How did that work out in Gothenburg? Tell us more.
Well, we actually got 3 different types of vessels. We got a pilot boat, a yacht, a princess yacht, and we installed also a system in a RoPax, which is a ro-ro that also carries passengers. And in there, we installed the systems, and we do some situations where we got somewhat close to each other, and we got to see the predictions of the other ships. So that's an important component of the system that we developed. My predictions can be shared to other vessels so that they can see where I'm going to be and I can see where they're going to be, and then try to evaluate what the people sailing these vessels thought about these predictions, how they're useful to resolve situations. When it comes to the machine learning part goes inside of this system that we made, and it's the calculation of these coefficients, but also the monitoring of the predictions. So the moment that the system says, like, your predictions are actually not that good at the moment because of whatever reason, it shuts the system off as a safety so that the person operating the vessel doesn't rely on predictions that are unreliable.
Yeah, no, that's great. So it removes the idea of false confidence. No, that's excellent. Okay. And how precise and accurate did you manage to go?
The predictions?
Yeah.
Well, it's a little. It depends quite a lot on the weather conditions and what kind of ship. The larger the vessel, the more accurate it is. A small vessel like a pilot boat, they're planning, and then the models that we use to model the motions of the ship, they're much more complicated when it's a planning vessel. But for big ships, I would say that we got quite sufficient accuracy to make the system useful.
So what, more variables in a smaller ship?
Well, the smaller ships, as they start planning.
Right.
So there's 2 types of, you could say that there's 2 types of vessels, like the ones that displace the water, like big ships, and then the ones that really go so fast that suddenly they lift off and they're kind of like planning on the surface.
Oh, okay.
But the physics of that is much more complicated than the other one. And so coming up with a good set of equations to describe that and how the forces are going to move the ship, it's quite difficult.
So that's the next phase.
Yes.
Yeah.
Yes.
Well, this is excellent. Thank you so much. The work behind this, it's very complicated, and there's there's computational work involved, and obviously mathematics and so on. It's very intricate. Luis, why did you get drawn into all of this? It sounds, someone with no mathematical ability whatsoever, it sounds quite kind of intense. What attracted you to this?
Well, I'm an naval architect by training, and I like maneuvering. I think it's nice to do simulations about where a ship could be, and then suddenly we have all these tools and machine learning, neural networks, and then the question is, can we use them?
Yeah, and also for the future because of autonomous vessels.
Yeah.
Can you tell me a little bit more about how that would feed in? I mean, in your own words, why is it important?
Well, for example, the model that we have, the predictor system that predicts the future motions of a ship, it has a dynamic model of a vessel. And an autonomous vessel is going to require a dynamic model of the vessel. So this could be a component in an autonomous vessel to actually allow for an autonomous navigation system to steer that vessel.
Absolutely. We think of smart motorways with autonomous vehicles, but it's true, of course, the sea is also like a highway. And yeah, so then that kind of infrastructure for the vehicles to, in this case, the vessels, to be able to sense where they are and let other ships also predict where they're going to be, obviously is crucial. Yeah.
Well, it's more about it's about control. Like if you have a computer and you want to control something, usually the computer needs to have an understanding of what is it controlling.
Yes.
So then in some sense, what he got created in the context of autonomous vessels, it could be like that model that helps the computer to control. So that's one thing. Then in this project, we also have these communication systems. So then you could think of two autonomous vessels. They communicate to each other their route, their current motions, and where they're likely to be. And they can use this information to plan their movements in a better way and avoid incidents.
Super. Absolutely. Thank you. Thank you very much. Very interesting. Does anyone have any questions for Luis? Yes, Franz, what would you like to say? Maybe it's an observation.
Well, yeah, it's more of an observation. In our project, we have looked into the positioning, the most optimal positioning of the ship. So it's not really predicting maybe the movement of the ship, but in case of a rather large ro-ro ship fire, how to best position the ship to make sure that you, for example, limit fire spread, or that you give as good conditions as possible for evacuation. So I don't know if any of the research you have done, Luis, do you think any of that could impact like in a fire situation?
I mean, I guess that this dynamic model, if you think of, okay, there's a fire, and then you want to position the ship in the best possible way because help is on their way. But you don't want people in the breach to start to move the controls because you want them to evacuate.
Yeah.
So then you could think of an autonomous navigation system that steers that ship just to make it easy for everybody to get out and for fire control or the fire brigade to take care of the situation.
Right.
Meanwhile, on board, Lazarus's system is letting everybody know whether to turn left or right by buzzing at them if they're dark and it's confusing and it's all stressful. Look at you guys. You've got us all safely taped up. Thank you very, very much for all your work. It does genuinely make me feel much more positive about the future of being on boats. Thank you. Thanks for your time, guys, and for being with us today.
Thank you for having me. Thanks a lot.
Thank you very much.
Thank you very much.
Yeah, very welcome. That was super. Thank you. If you've enjoyed this podcast and are interested in the latest scientific research coming out of the EU, have a listen to previous episodes. Follow us on Spotify and Apple Podcasts or whichever podcast provider you favour. Are you curious about what other EU-funded projects are doing in the area of maritime safety? The Cordis website will give you an insight into the results of projects funded by Horizon 2020 and Horizon Europe that are working in this area. The website has articles and interviews that explore the results of research being conducted in a very broad range of domains and subjects. From nematodes to Neanderthals, there's something there for you. Maybe you're involved in a project or would like to apply for funding. Take a look at what others are doing in your domain. So come and check out the research that's revealing what makes our world tick. We're always happy to hear from you. Drop us a line. editorial@cordis.europa.eu. Until next time.